Well, good morning, everybody. Welcome to Launch Complex 40, where we are processing Falcon 9 for launch in November. A little bit about this launch pad. It's an old Air Force launch pad. Launch Complex 40 was a Titan 3, then 34D, and then the Titan 4 launch pad, which we're operating under, or we're operating on under a license from the Air Force. So the Air Force licensed us the pad for a 5-year period and enabled us to basically build out what we needed to do our launch process, and we're hoping to convert that to a long-term lease here pretty soon. I'm just gonna, you know the drill. So a couple things to know. First off is we're up here in what I call the heavy lift zone. So if you look to our north, you would see the Atlas V pad sort of straight behind the bus. And if you look to the south, you'll see the Delta IV pad where you just came from. And then obviously this is our launch pad off to the right. A couple of key features you'll note: our transporter erector is in the vertical position right now, undergoing tests. Normally it is in the horizontal position and only spends just a little bit of time in that vertical position, but that's what actually lifts the rocket from the horizontal position up into the vertical position. You'll also notice the 4 lightning protection towers. Those are remnants from the Titan days. You can see the flame duct just off to the right here. So that's actually where all of the acoustic energy and thermal energy coming off the base of the rocket gets thrown out away from the pad. And you can see a couple of things we've done uniquely to this booster is we've added that gray steel structure, and we actually just drop water out of that, a lot like a car wash, so that we knock down all the acoustic energy so it doesn't bounce back up and vibrate the rocket as it's leaving the pad. Some of the other things you'll note, obviously that transporter erector, you can see the 2 big hydraulic pistons that drive that from the horizontal to the vertical. The transporter erector has 4 launch hold downs which hold the rocket down. So we actually light the rocket at -3.5 seconds, and then at about T plus 0.5 seconds, if the flight computer senses that all 9 Merlin engines are burning at 100% and all the pressures and temperatures look good, the hydraulic clamps release and then let the rocket fly. So we actually light it and hold it down, checking to make sure everything's good. The Falcon 9 is a liquid oxygen RP1 booster, so you can see the 110,000 gallon liquid oxygen tank just off to the right here. That's actually an old Apollo 1 tank that we purchased for $1 over scrap value and then refurbished it. So it was a good deal for us. On the other side of the pad, you will see 2 28,000 gallon RP1 or refined kerosene tanks. And what I'm going to propose is that we stop here. What do you think, Brad? We can go up to, if you see the yellow chain there, we could go up to there if you want to get the group out. Okay. Excellent. Then we'll talk a little bit more when we get out to the base of the pad. So if you can just pull up, you're going to be in, so if there's any issue, you can pull her out of the way. So real quickly, as the last folks are going to get out of your guys' view unless you want. The booster's being processed in this integration facility right now. Unfortunately, we're right in the middle, as we build up for launch, of hazardous operations, so we can't go in the hangar. But what you notice is 2 of the things that were left over from the Titan program were these rails. They used to go about 5 miles to the south, back to some other facilities. We kept those rails, so we actually, as you'll see, when that thing comes to the horizontal, we'll rotate that whole transporter erector down and then roll it right on these tracks into the hangar. We'll lift the hangar up using 2 20-ton cranes, or excuse me, the booster using 2 20-ton cranes, drive that underneath it, lower it down, clamp it down, and then it's ready to roll and go. So we can walk out a little bit closer to the rocket. If you see the clamp arms there, that's right just above the second stage. So it goes about probably 15 feet in the current configuration with the Dragon capsule. It goes about 15 feet above the top. It's about 203 foot. Now the whole concept here of horizontal integration is the idea is we'd like to be able to keep the booster inside of a protective hangar most of its lifetime. That way the technicians can work on it. It's right here at hand level. And the idea is we want to get down to opening the hangar door, rolling out, going vertical, fueling and launching in 1 hour. That's our goal. Now right now we're at about 24 hours because we're taking it nice and methodical, making sure we understand the process. We're taking a lot of the manual sequences and automating those. So we've got a little ways to go to get to roll out and launch in 1 hour, but that's what drives a lot of what we're doing out here at the launch pad.
So, Mr. Henderson, is the motivation for that profit or cost based to some degree?
You know, it's not primarily driven by that. It's really primarily driven by a booster's better off inside, air conditioning, and down where you can work on it so you're not dropping tools and other things from high heights. But in the end, if you can get to 1 hour roll and go, that enables you to crank them out. You know, if things don't look good, you roll it back in the hangar. It gives you the ability to load things late in the game. If you're going to resupply space station, for example, you can load stuff in the last hours right before you roll out. But one thing you'll notice about our pad is there's no gantries. So when we modify Falcon 9 for manned launch, we're going to have to add some crew access and so forth. So that would be one of the things. So when the booster, on launch day, when the booster rolls out and goes into this vertical position, it's basically a 12-minute operation to go from horizontal to vertical. So you get into vertical, we plug in quick disconnect lines for the RP1 and the liquid oxygen down at the base to fuel the first stage, and then you can see up at the top, just near those clamp arms, is where those will actually wrap around the booster, and just below that is where we plug into the second stage. So you get an idea. The first stage goes up to right about where those two big white ducts start, and then that's where the second stage and payload are above that. Now once we fuel the booster with LOX and RP1, about 20 minutes prior to launch, we actually pull the transporter erector back from the 90-degree position to the 78-degree position, clearing it from the booster and prepping for liftoff. So one of the key things you got to do when you lift off is first you do that burn, get all the engines revved up, and the computer's right so that those hydraulic clamps release. And then you got to fly. You can see the lightning protection catenary wires. You have to fly through that square up there, which isn't a big deal. I mean, if you're straying off course by that much, but I mean, when you look at it, it's a little bit deceiving as to how tight that really is. And then you can get a good view. I was mentioning where we are relative to everything. You guys can see a good view of the two shuttle pads straight through the gap there. So when shuttle or Atlas launch, we have to clear the pad. When Delta IV launch is heavy, we have to clear. So we all impact each other to some extent. From the very top of the tower, this flight is one of our demonstration flights getting to that capability. We've got 12 on contract with NASA to resupply station. Obviously, we're hoping to we can get to station with cargo. It's a really straightforward step now there at hand. So, yeah, I think it's exciting. Yeah, absolutely. I mean, we think that the fact that the manifest is robust for the next years. Falcon 9 is so you know, I think there is room for optimism.
Just for the tape, your name and
Scott Henderson, Space Explorations Technology. My title is the Director of Mission Assurance and Integration.
So you got a lot of hats.
Right. That's a good way to put it.
And tour director.
Yeah, that.
Show demo stuff.
Vertical position right now, undergoing tests. Normally it is in the horizontal position and only spends just a little bit of time in that vertical position, but that's what actually lifts the rocket from the horizontal position up into the vertical position. You'll also notice the 4 we needed to do our launch process, and we're hoping to convert that to a long-term lease here pretty soon. I'm just gonna, you know the drill. So a couple things to note. First off is we're up here in what I call the heavy lift zone. So if you look to our north, you would see the Atlas V pad sort of straight behind the bus. And if you look to the south, you'll see the Delta IV pad where you just came from. And then obviously this is our launch pad off to the right. A couple of key features you'll note: our transporter erector is in the... Well, good morning everybody. Welcome to Launch Complex 40. Where we are processing Falcon 9 for launch in November. A little bit about this launch pad. It's an old Air Force launch pad. Launch Complex 40 was a Titan 3, then 34D, and then the Titan 4 launch pad, which we're operating under, or we're operating on under a license from the Air Force. So the Air Force licensed us the pad for a 5-year period and enabled us to basically build out what